The story of the atomic bomb is one of science, war, and an unprecedented race to unlock the secrets of the atom. A journey that began as pure scientific curiosity led to one of humanity's most destructive creations. This is the tale of how some of the greatest minds in history, driven by the urgency of war, engineered the atomic bomb, a device that forever changed the course of history. Our story begins long before the bomb itself. In the late 19th and early 20th centuries, scientists were beginning to explore the hidden power of the atom. Atoms were once thought to be indivisible, but this idea was shattered by discoveries that revealed their complex inner structures. In 1896, French physicist Henri Becquerel discovered radioactivity, followed soon after by Marie and Pierre Curie, who isolated radioactive elements like polonium and radium. These breakthroughs hinted that tremendous energy lay hidden inside the atom. Fast forward to 1938 in Berlin, Germany. Two scientists, Otto Hahn and Fritz Strassmann, conducted an experiment that would change everything. They bombarded uranium atoms with neutrons and discovered something extraordinary. The uranium nucleus split apart, releasing a massive amount of energy. This process, known as nuclear fission, had been theorized but never proven until that moment. When physicist Lise Meitner and her nephew Otto Frisch analyzed the results, they realized they had uncovered something world-changing. They coined the term fission to describe the splitting of the atom. The energy released during fission was immense, and they knew it could potentially be harnessed. As World War II loomed, scientists across Europe and America quickly understood the implications of nuclear fission. Could this energy be turned into a weapon? And what if Nazi Germany got there first? In 1939, Hungarian physicist Leo Szilard and fellow scientists, including Albert Einstein, wrote a letter to U.S. President Franklin D. Roosevelt. They warned him that Germany might be developing an atomic bomb and urged the United States to begin its own research. This letter was the spark that ignited what would later become the Manhattan Project, America's top secret mission to build the atomic bomb. In 1942, the United States formally launched the Manhattan Project, a massive and covert operation that brought together the brightest minds of the time. Under the leadership of General Leslie Groves and physicist J. Robert Oppenheimer, scientists and engineers worked tirelessly to turn theory into reality. The project spanned multiple locations across the U.S., with its epicenter in the remote desert town of Los Alamos, New Mexico. Here, the team would design and assemble the bomb. But first, they needed the materials. To make an atomic bomb, they required fissile materials, specifically uranium-235 and plutonium-239. Uranium enrichment. Naturally occurring uranium contains less than 1% of the isotope U-235. To create a bomb, the scientists needed to enrich uranium, increasing the concentration of U-235. This was an enormous challenge, requiring enormous factories and innovative methods like gas diffusion and electromagnetic separation. Plutonium production. Plutonium, on the other hand, did not exist naturally in sufficient amounts. Scientists at places like Hanford, Washington, used nuclear reactors to convert uranium into plutonium. This process, while groundbreaking, brought its own dangers and required rigorous precision. By 1944, the fissile materials were ready, but now came the even greater challenge: how to create a bomb that could trigger nuclear fission in a controlled way. Two designs emerged. One, the uranium bomb. Little boy. This design was relatively simple. A conventional explosion would fire two pieces of uranium-235 together, achieving critical mass and triggering a chain reaction. Two, the plutonium bomb. Fat Man. Plutonium was far more unstable than uranium. To detonate it, scientists devised an implosion method. A sphere of plutonium was surrounded by conventional explosives, which compressed it inward, causing a chain reaction. Countless tests, calculations, and experiments were conducted, pushing the limits of what was known about physics. The scientists at Los Alamos knew that failure was not an option. The true test of their efforts came on July 16, 1945. In the remote desert of Alamogordo, New Mexico, the world's first nuclear bomb was prepared for detonation. This test was called Trinity, a name chosen by Oppenheimer. At 5:29 a.m., the bomb exploded, releasing a blinding flash of light and a fireball that expanded into a massive mushroom cloud. The force of the explosion was unlike anything seen before, equivalent to 20,000 tons of TNT. The scientists had succeeded. The bomb worked. But they also knew they had unleashed something terrible upon the world. With the war still raging, the United States made the decision to use the bomb against Japan. On August 6, 1945, the uranium bomb, nicknamed Little Boy, was dropped on the city of Hiroshima. 3 days later, on August 9th, the plutonium bomb, Fat Man, devastated Nagasaki. The effects were catastrophic. Tens of thousands were killed instantly, and countless more suffered from radiation exposure. The bombings ultimately led to Japan's surrender on August 15, 1945, ending World War II. The making of the atomic bomb was a turning point in human history. It showcased the power of scientific achievement, but also the horrors of unchecked destruction. The Manhattan Project, born out of a race for survival, ushered in the nuclear age, a time when humanity held the power to destroy itself. In the years following the war, atomic weapons became symbols of both power and fear. The Cold War saw nations amass arsenals of nuclear bombs, sparking decades of tension and uncertainty. The scientists who worked on the bomb carried their own burdens. Some believed it was necessary to end the war, while others, like Oppenheimer, expressed deep regret over the devastation it caused. The story of the atomic bomb is a complex tale of ambition, science, and morality. It forces us to grapple with difficult questions. How far should we go in the pursuit of knowledge? What responsibilities come with power? And can humanity ever truly control what it creates? From the moment of discovery to the deserts of New Mexico, the making of the atomic bomb is a reminder of what we are capable of, both good and evil. It is a story that must be remembered not only for what it achieved, but for the lessons it taught us about the consequences of our actions.